Thank you for clicking on the help video. Here I'm going to explain I'm going to explain how to draw the transformation of a function f with the combination of both a vertical and a horizontal shift. So we're given here that g of x is equal to f of x plus 2 minus 5, where the graph of f is going to be in red. And we have two of them here. So this graph right here on the left is one version of f, and the parabola here on the right is another version of f. And we want to draw again the graph of g. So for both of these, we need to understand what this notation means and how that correlates again to this red graph. Over here, we're combining two transformations. We're combining a horizontal transformation, which is denoted by f of x plus 2, and a vertical transformation, or specifically a vertical translation of minus 5. So this plus 2 is going to cause a horizontal shift, a translation in a left and right direction, and the minus 5 is going to be a vertical translation in up and down direction. Well, the directions again correlate to the operation that we're doing. With horizontal, it's the opposite sign of what we see. So x plus 2 doesn't mean to move this graph 2 units in a positive direction. Nope, it does not. It means to move it 2 units in a negative direction, so to the left of 2. Now, for the vertical one, it correlates directly again to the notation that we see. So minus 5 actually means to move the graph 5 units downwards. So this notation means to get this function of f, simply slide it 2 units to the right, to the left, and 5 units down. So to do this one, to do that with the graph on the left, I want to use, first of all, this again turning point, which normally with the parent function would be at the origin, and then any other pretty point. So let me find another pretty point right here, 1, 7. So 1, 7, and this one is negative 1, negative 1. So we want to move those 2 points. So if I move those 2 points 2 units to the left, 1, 2, and then 5 units down, 1, 2, 3, 4, 5 right there. And the same thing with this point, 2 units to the left. Let me do it in yellow. 2 units to the left, and then 1, 2, 3, 4, 5, and plot that point. The software will automatically draw this, again, cubic function, which is what this is, and draw you this entire function as such. Now, it's not the best looking one, but again, you just need to plot those 2 points, and then the computer will do the rest of the work for you. Now, you do need to use, again, this one. You don't want to use another pretty point over here and then that one, because this first point that you plot, that's going to identify it as this position, this original position there, and then draw you the rest of it. Similarly, again, to this one right here, you don't want to use any 2 points. You want to use the vertice as your first point, and then picking any other point to draw that. So right here on the right, that one at 2, 1, and then any other point. Let's use this one at 0, 5. And we're going to just simply do the same thing, move those 2 points in the direction of negative 2 and negative 5. So 2 to the left and 1, 2, 3, 4, 5. So negative 4, 0. I'm sorry, 0, negative 4. And then the same thing here, 1, 2, and then 1, 2, 3, 4, and 5, negative 2, 0. And then our parabola will be completed. So that's how you do a transformation that combines both a horizontal and vertical translation.